I'm back with another proof. So I know I'm making this video after quite a long while, but just get started with any further delays. So we have been asked to prove that the fractional part function of m by n plus the fractional part function of n by m is not equal to 1. We have to prove this when both m and n belong to the set of all positive natural numbers, 1, 2, 3, and onwards. So let's start with the proof. We'll start by writing what m by n and n by m actually are. So m by n is the GIF of m by n plus the fractional part function. And we can break n by m like this. So we'll have no problems. Right. So after this, I'm just wanting to extract the fractional part function from this. So by some transposition, we will get m by n minus this. And similarly, we will get this. What we did is we just basically transposed this thing to that side, my to this side, and get this alone. So for this, we are going to assume that this the counter statement of the question into by contradictions for this. So let's assume this to be 1. Now from the previous slide, you can rewind the video and see that we'll be substituting these values. So we have m by n, which is this, and we have n by m, which is this. Now I'll be transposing the greatest integer functions to that side, to the RHS. Let's just do that really quickly. So we've got this. Now I want you to realize that this thing is an integer. It's a natural number, in fact. And m and n are natural numbers, and this is the greatest integer function. So this is also going to be a natural number. Now this is also going to be a natural number. So we can just write, we can say that this entire thing is equal to k, and k belongs to n, the set of all natural numbers. And after that, we can write it like m by n plus n by m is equal to k, where k is equal to 1 plus, I'll just copy this thing. I'll bring it over here. Yeah. So yeah, we've written this, and k belongs to n. So for this, we can say that let the GCD of m and n, we're doing this to simplify it, let it be d. So m is equal to AD, n is equal to BD, and so AD by BD plus BD by AD is equal to k. From this, I just changed m by n to its m and n to its GCD form. So we can cancel these, and we'll get this. So we'll be left with this. Now I'll be taking the LCM and write it like this. And I wanted to see one thing. If a squared plus b squared, uh, wait a minute, what did I do? Yeah. So this, you can write it like a squared plus b squared over ab is equal to k. And now since k is a natural number, the both of these terms must be perfectly natural numbers, and that means they should leave no remainder after division. So that just means that b divides a squared from this, which implies that b divides a, and this implies that a divides b squared, which again implies that a divides b. That's great, but we know that the GCD of m and n was d. So if a and b are also dividing each other, but since d was the GCD, a and b must be co-prime. But if they're dividing each other, that means that a and b, both of them are equal to 1. That's the only way they can divide each other. Otherwise, it's not possible. So if a and b, both of them are equal to 1, we can say that A is equal to 1 is equal to B. So M is equal to AD is equal to D, because A is 1, and N is equal to BD is equal to D. So because B is also equal to 1. So M is equal to N is equal to D. Let's write it now. M by N plus N by M is equal to 1, and this is going to be D by D plus D by D is equal to 1. Now this is 1, this is again 1. Now, if you see the fractional part function, it gives the fractional part of the part of the number after the decimal. So whatever x is, when we are given this, the fractional part function of x, it always belongs to 0 and 1. It's always this. It can never be 1. It can only be less than 1. So if if we are given 1, and if you find the fractional part function of 1, it's got to be 0. So 0 plus 0 is equal to 1. But we know that 0 plus 0 is 0, and 0 is not equal to 1. So therefore, we assume that this was going to be 1, but it's not 1 because 0 is not equal to 1. So our assumption was incorrect. Our assumption was incorrect, and we can say and m by n plus n by m is not equal to 1. And that's it, ladies and gentlemen. We have proved this question, and I hope you like this proof. And if you guys are interested in some other questions or proofs, please leave them down in the comment section. Thank you for watching.